known as kind of she described it as a kicker, which made the virus kind of hype into overdrive and really infect the cells that she was working with. And then she used two different drugs, one that she developed and one that was previously used to cure malaria, to try to reverse the effects of the virus. And the virus, fun fact, causes cancer because it makes the cells rapidly produce in an irregular fashion, and so most of her research focused on oncology. So I kind of had two aspects going in there. We worked with various different tools, including the hood, and I don't know if you can tell, but it's about 2 feet deep by 4 feet wide, and we were sitting next to each other, and I'm left-handed. So I spilled a few things, but it was a fantastic experience. I got to work with different tools such as microscopes to look at cell confluence, which is when the flasks get completely filled with cells, and cell death. And these are some of the tools I worked with, including a micropipetter. And this is my favorite because most college sophomores don't get to work with a micropipetter, but I held one almost every time I went there and got to play with it. I'm very happy about that. And if her research takes off and she gets published with one of these medicines, I could say, I held the micropipetter. That helped start it all. I did my research on a different aspect of virology. There are two aspects of viruses. There's the catastrophic side, such as Ebola, and then there's the beautiful side, the wonderful, helpful tool of phages. In the second day of my sitting in on a lecture with Dr. Lewis, she mentioned in passing the term phage therapy. And I wrote it down in my notebook with a little star by it because I was like, I have no idea what this is. So I came up to her at the end of class and she explained it to me. And phage therapy is an alternative treatment for bacterial infections. How many of you are aware of the antibiotic resistance problem? Oh, good, most of you. You all probably took Mr. B's class. So for those of you that don't know, bacteria, especially with the overuse of antibiotics nowadays, have grown quite a strong resistance to antibiotics. For example, one of the ones I talked about in my research paper was MRSA, which is potentially pretty fatal, and especially now that it's grown such a strong immunity to the antibiotics we have in place, if it's not treated immediately, even in first line disease, it can be fatal. So my research question was, is phage therapy a viable alternative to antibiotics in treating bacterial infections? This is not a real one, it's drawn, of a bacteriophage. And a bacteriophage is a type of virus that specifically targets bacteria. And the wonderful thing about this is antibiotics are typically cause side effects. You guys have had strep throat, I'm sure, and the headache gets even worse once you take the antibiotic. No fun. With phage therapy, because it specifically attacks the bacteria and doesn't affect your body at all, you will have no side effects. And also, because it's in a coevolutionary arms race with the bacteria, there's no way that the bacteria can develop an immunity without evolving much more rapidly than it already does. So my question for my research paper, I think I already stated, my answer was absolutely yes. The only problem is there's not been enough positive test results in the lab to determine whether or not we can make the switch from antibiotics to phage therapy. But of all the research I did, most of them were pretty positive. There just haven't been any yet. So for my community service, I taught a class with Ms. Phillip, with a selfie. And I used a lot of the research that I learned in Dr. Lewis's class to give this. I talked about mechanisms, some of the history of virology, and how vaccines work, and how you should protect your body so you don't get viruses. They also took a quiz, and after that they did a little lab, which was awesome. Unfortunately, I couldn't do a virology lab because as a high school student, it's really hard to get your hand on a dangerous virus. So we studied bacteria instead, and we focused on how temperature affects bacterial growth in milk. As you can guess, the room temperature milk was the most disgusting, and I got to stir it. And then they used a color indicator to determine how much bacteria approximately was in each of the test tubes. Blue meant very little or no bacteria, pink meant quite a bit of bacteria, and clear meant it was so much bacteria it's not even milk anymore. Not only is my lecture included in the curriculum for Bio2 Human Systems now, I'm also planning a field trip for the Bio2 class to go to University of Mary Washington to get a tour of the Science Center, which is going to be, a wing is going to be added on it in 2017, and their growing nursing program. And the professor is willing to stay after lunch and talk with them about pursuing a career in the medical field. This is also where I'll be going in the fall. I fell in love with it when I visited this spring, and I already know my biology professor, so it's okay. The most important thing I learned about my legacy portion is that when you have to plan something that involves multiple people, you need to leave room for communication time, because something I thought would take a week ended up taking over 4 months. So I started planning my legacy in December, and by February we finally had the go-ahead from both sides, and I finally sent in the date I wanted to do it in February, and they said, "I'm sorry, Ms. Vassie, but the months of April and March are completely full for group tours. So May 24th, we're going to be having our group tour there." And my advice to VRVGS upcoming students: this is a trash can. And this was actually pretty devastating. I think it was about a month after I started working with Sarah Murphy. We lost 11 flasks of dead bacteria because of an accident, completely unbeknownst to us until we got there and opened the CO2 incubator and realized that it wasn't turned on correctly. So we lost essentially months of research, and we were both very pretty devastated by that. But I was really impressed with her grace and poise throughout this calamity, and it made me realize that in both science experiments and in life, you could do everything right, you could try your hardest, and sometimes things still fall apart and end up in a trash can. But my prayer for all of you upcoming VRVGS students and everybody is that you pick something in your life and in your career that will inspire you so much that even if you're met with failure, you will look at it as an opportunity to keep moving. Thank you.
I'm going to let Mr. ask your question. So what hope do you think there is for, I feel like when you start bringing up the idea of using viruses to treat infections, like I feel like you're triggering a somewhat like negative response in people. So like, did you look at anything about like, I guess like phage therapy could be really effective, but if people aren't willing to buy into it as like patients, then maybe it's going nowhere. Did you see anything on like that perception, or is it still too early maybe to get into that?
I actually talked to Dr. Lewis about this, and it is kind of early to tell because it is, like you said, kind of a fear factor using viruses to cure bacteria. There hasn't been a whole lot of funding for it. All the tests I found in my research paper had pretty positive effects, or none of them were negative, but there isn't a whole lot of funding, so there isn't like, they're not willing to make the switch yet because there haven't been just enough. But she did say once that people start seeing the results that she hypothesizes, and she's pretty smart, that for in the next decade, she said 2 or 3 decades, she could see us making the switch because antibiotic resistance is enough of a fear factor in itself that it might be plausible to switch over to something else.
Is it true? Let's dumb it down a little bit. Is it true that the reason that we are not doing a lot of antibiotics is because we're giving them too often? That's why we have to look for a different type of work? Like, is it because we give antibiotics for so many things that our bodies start saying, well, this isn't going to work anymore because we've had it too much? Is that
overuse is definitely a problem, and it's not just that your body is kind of getting used to the effects of antibiotics, it's also that the bacteria, once it's been in contact with the antibiotics so many times because we overuse them, it mutates to the point where it can combat it and even get stronger because it has that extra layer of shielding. So, yeah. And I could just talk about one of the research paper points that I found. I thought was fascinating. They put bacterial meningitis in a bunch of rats, and after 3.5 hours of a phage therapy treatment, the bacterial count was reduced by 50%. So that was the kind of research I found. So way better than antibiotics at that point.
Thank you so much.